Do you ever wonder how exactly information travels through the world? Well, we're about to unravel the secrets of fiber optics. I hope you're ready to be enlightened. There are two main parts of an optical fiber. There's the core, which is the inside of the wire, it's where the light travels, and then the cladding, which is added to the outside of the core and traps the light inside it through a process called total internal reflection, since it has a lower index of refraction than the core. Now, those are some big words, so let's break down what they mean. If light hits a surface, there are two things that can happen: reflection or refraction. Reflection is the light that bounces back off of a material. Think of light reflecting off a mirror or a car, or these six shades. Refraction is the amount of light that shines through a material. Index of refraction is a measure of the speed with which light travels through a material, and changes in indices of refraction is what causes light to bend, like how the pencils in this cup of water look warped. Total internal reflection means that there is no refraction. All of the light is reflected, as shown in this photo of light being reflected inside a stream of water. This is ideal for fiber optics because it decreases power attenuation, which is really just a fancy way of saying loss of power. However, there are other things to worry about that can cause power attenuation. Rayleigh scattering can also happen at shorter wavelengths of light, which is the interaction of light with inhomogeneities in the fibers, for example, density fluctuations or composite fluctuations. There's also another problem entirely, which is called dispersion. This happens to pulses of light over time. They spread out, or disperse, hence the name dispersion. Instead of being a quick, powerful pulse of light, they become a longer, weaker pulse of light. Imagine a dish of ice cream with 3 scoops of different flavors all in a row. Right after they've been scooped, you can still tell which scoop is which flavor, but after a certain amount of time, they start to melt and run together, and you can't tell where one flavor ends and another begins. This is the same thing that happens to light pulses. They run together. But don't worry, there is a solution. Erbium is this lovely material that makes fiber optics possible. It amplifies the pulses of light through a process called stimulated emission, which is what happens when a photon makes a small perturbation with an erbium ion, causing it to fall from an excited state to the ground state, which emits another photon that hits another ion, eventually causing a cascade of photons with the same frequency and phase, enabling signal amplification. An easier way to think about it is the erbium ions are dominoes in a row, and a photon comes in and pushes over just the first domino. Now a chain reaction begins, and each domino causes the next to fall. The continuous falling of dominoes is representative of the signal amplification as more and more photons are released through stimulated emission. Well, that wraps up our journey through the shining world of fiber optics. Next time you're looking at a video of a cat chasing a laser, I hope you think about stimulated emission and the illuminating role of erbium.